In this video, we're going to take a look at our upper integral, we're going to take a look at our lower integral, and then finally we're going to get to the Riemann integral. And so here we suppose that f is a function that's bounded. It's defined on a closed interval a to b. The upper integral of f on that closed interval a to b, it is defined to be the infimum of all of these upper sums when you consider every single partition of the closed interval from a to b. So if you look at all of those partitions and consider every single partition and look at every single upper sum that you can get, if you find the infimum, the greatest lower bound of all of those upper sums, that greatest lower bound is the value of that upper integral. And similarly, for our lower integral, instead of looking at infimums, we look at supremums. And so we look for the least upper bound. Right? So we have a supremum over all of these. Those should be L's. So the supremum over all of the lower sums, and when we look over every partition of the closed interval a to b. If it turns out that the two sums are equal, so if this upper integral and the lower integral, if those two integrals are equal, then we say that f is Riemann integrable, and we denote that common value by this or by this. That value is known as the Riemann integral, right? And so when our least upper bound for the lower sums is equal to the greatest lower bound of the upper sums, then we would have a Riemann integral, and it's Riemann integrable. There's a couple other theorems then associated with this. So if we have a bounded function on a closed interval, if P and Q are both partitions of AB and Q is a refinement of P, right? Then the lower sum of f and p, right, that is going to be less than or equal to the lower sum of that refinement on the partition Q. And that lower sum should be less than the upper sum of the refinement on that partition Q. And the upper sum without the refinement should be larger still. Right? So we get this string of inequalities where the refinement gets us closer to having these two values that are equal. We also have, if f is a bounded function on closed interval a to b, the lower integral, that should always be less than or equal to the upper integral. All right, in our next video, we will take a look at an example where we find the upper and lower integrals and use some of these ideas to analyze that. All right, we'll see you there.